2 weeks. Push it and then we're done. Just 2 weeks. Okay, today we're doing sketching graphs using maximum and minimum values. I remember last week you asked me whether we're going to be using these things to draw the graphs. So this is the part where we're going to be putting, I think you or Chema, one of your asked that. Yeah. So this is where we're going to be using what we did last week, right? So I'm on page 234. Okay? They give a nice example there of how we're going to use this. So we're going to do that, right? Okay, so you know for intercepts on the y-axis you let x equal to 0. For intercepts on your x-axis you let y equal to 0. So I'm going to do the example that they give you. So the example is if y is equal to x minus 1, x plus 1 and x minus 4, they first want you to calculate the critical values. Okay? From what we did last week, what is critical values?
X.
Of?
Unit of F.
7.
Again? Where you get these x values, what you need to do? First, you need to get your first derivative, and those x values are your critical values. Okay? So then they want the critical values here. What we first need to do here? We need to derive, right? Okay, so last week we learned something called the, which one would you use here? You multiply to get the derivative of these brackets. Which rule?
Let's
start thinking now.
Okay, remember last week, right? Okay, I don't think a lot of you were here. We did 3 rules. The chain rule, the product rule, and the quotient rule. Now what is the chain rule used for? Function of a function. Product rule is used for? Multiply. Quotient rule is used for? Dividing. Okay? So in this instance here, what do we have? You multiply. So you're going to be using the product rule. Now this is the product rule for 3 factors. Okay? So remember, we'll call this one here U, this one here V, this one here W. Okay? Now what does your product rule state? Okay? Your product rule states that dy over dx is equal to u times v times dw over dx plus u times w times dv over dx plus v times w times du over dx. So it's equation u times equation v times the derivative of equation w with respect to x. So now we substitute it into the equation. So this would be x minus 1, x plus 1, d over dx of x minus 4 plus x minus 1 times x minus 4 derivative of x plus 1 plus x plus 1 times x minus 4 times the derivative of x minus 1. Product rule for 3 factors, right? Okay, so now we just need to work it out. So x times x is x squared. This plus 1 and minus 1 will cancel that middle term, right? So you're left with minus 1 squared, which is minus 1. You're with me, right? Yeah. The derivative of x minus 4 is what? Remember, you'll derive x, you'll derive minus 4. Okay? The constant will become 0. This x would become 1. Plus, this here would become x squared minus 4x minus 1x is? Because remember, you'll end up with minus 4x and you'll end up with minus 1x. So this would become minus 5x. 4 and 1 would make it positive 4. Derivative of x plus 1? 1. Plus x times x is x squared. Minus 4x plus 1x is, and then you end up with derivative of this 1. Okay, so you have to x squared minus 1 plus x squared minus 5x plus 4 plus x squared minus 3x minus 4. So far, guys, everybody with me? Okay, so this becomes 1, 2, 3. 3x squared minus 5x minus 3x minus 8x minus 1 plus 4 is 3 minus 4 is minus 1. Okay, so this here is dy over dx. Okay, so remember, for your max or minimum point, your first derivative must be equal to 0. This is our first derivative, right? So it's 3x squared minus 8x minus 1 equal to 0. So now if you have to factorize this, or if you use your quadratic formula, what do you end up with? Okay, so let's use the quadratic formula, right? So the quadratic formula is x is equal to minus b plus minus the square root of b squared minus 4ac all over 2a, right? That's the quadratic formula. So your values of x here would be equal to minus 8 plus minus the square root of minus 8 squared minus 4 times 3 times minus 1 all over 2 times 3. So x is equal to, and so if you put this in your calculator with plus first, it will give you one value of x. If you put it in your calculator with minus, it will give you another value of x. So do that and tell me what you get. So guys, so far you understand that? What's going on here? This was using the product rule for 3 factors. It looks clean, but it's still, when you write it, it's gonna go.
What happened to the little spots?
Yeah, I don't know what happened to the thing, but we told him to swap it, put one board like how this one is. Doesn't have that spots on it. But I think only one time, and then after you see it, it's gonna give up. No. Writing looks neat, you know? Yes.
Yeah, no, we also supplies.
The results just really mark it.
2.786.
2.786. And then just go back to where you have this plus sign and make it a negative sign.
Minus
-0.1.
0.120. Yeah, that's right. Okay. So these are your, what are these known as? These are your critical values. Okay? Cool. Another way you could have done this, but why I did this one time is like me recapping for the product rule for 3 factors, right? Another way you could have done this was, you could have multiplied these brackets out. Okay? You would have ended up with a cubic function. And you could have just derived that. Okay? You would have still came to the same thing. Okay? That seems like a shorter way too, but you also got the product rule that you could have used. Okay? Now that we wanted the critical values, they want to know the turning point. How would you do that?
Basically, you must substitute x to the original
Okay, so you take your critical values and put it into your original equation. So, for turning point, I'm going to say f of 2.786 is equal to, and then you're going to put it there, so it's going to be 2.786 minus 1 times 2.786 plus 1 times 2.786 minus 4. Put it exactly like how I got it here, right, in the calculator. And then here you're going to say f of minus 0.120 equal to
This one is minus 8.209.
okay, and yeah. So your turning points are 2.786 and negative 2.09 and minus 0.120 and 4.061. So far, you guys with me?
Yes.
Okay. How do we know which is our maximum and minimum turning point?
Test.
How you do the test?
Derivative.
Second derivative. If it's greater than 0
It's minimum.
and if it's less than 0, it's a maximum. Okay. So your test, you're going to work out your second. So f of x was equal to x minus 1, x plus 1, x minus 4. First derivative was equal to there, right? 3x squared minus 8x minus 1. So your second derivative would be what? 6x minus 8. Okay, so it's going to be 6x minus 8. So now I'm going to substitute my critical value into this to see whether the value is greater than greater than 0 or less than 0. Okay, so your second derivative for your first critical value is 2.786 equal to 6 times 2.786 minus 8. And then second derivative for negative 0.120 is equal to 6 times negative 0.120 minus 8. Now what you get?
First one is 8.716.
8.716. And this one?
Minus 8.72.
Okay, so because your second derivative is greater than 0, this is a
Minimum.
minimum point. And because your second derivative here is less than 0, this is a. Everybody's with me? Anybody confused over anything? So this would be a minimum turning point, this would be a maximum turning point. Cool?
Yeah.
Anybody's confused? It's like exactly like how we did it the last week. It's just that everything is together now. It's like one question. Okay? Then take out a picture of it. And get this part.
Who's gonna post? You gonna post it?
No, you can post.
Okay, the next question, they want you to work on the point of inflection. Okay, how do you work on the point of inflection?
Second derivative equals to 0.
Second derivative equal to 0. So, okay, so for point of inflection, we lecture second derivative equal to 0. We worked on what our second derivative is. It's 6x minus 8. Okay, so 6x minus 8 would be equal to 0. So x is equal to 8 over 6, which is 4 over 3. Right? You're with me? And then how you get the corresponding y value?
Substitute
In your original equation. So your y value would be equal to 4 over 3 minus 1 times 4 over 3 plus 1 times 4 over 3 minus 4. Now what you get?
minus 2.074.
Okay, so your point of inflection is 4 over 3 and minus 2.074. Good? Everything we did already, right?
Yeah.
Okay. Then they ask you to calculate the intercepts on the axis and also sketch the curve. So now they want your intercepts, your x and y intercepts. Okay? So for your x intercept, you get y equal to 0. So for this one here, 0 will be equal to x minus 1, x plus 1, x minus 4. This is already factorized for us. Okay? So we just need to say x minus 1 is equal to 0, x plus 1 is equal to 0, x minus 4 is equal to 0. So x is equal to 1, x is equal to minus 1, x is equal, not x, x is equal to 4. So our 3 points we have here on the x-axis is 1 and 0, minus 1 and 0, 4 and 0. Fair? Okay. So for your y-intercept, you let x equal to 0. Right? If I let x equal to 0, when I get y is equal to 0 minus 1, 0 plus 1, 0 minus 4. I'm left with minus 1 times 1, which is minus 1 times minus 4, which is 4. So my y-intercept point is 0 and all with me.
Okay.
Okay? Now we need to just draw our graph. Okay? So how would you draw a graph? First thing you would start off with is your axis. This is your y, this is x. Okay, let's start with our x-intercepts points first, right? It's 1, minus 1 and 4. So this here is minus 1, 1 and 4. Okay? Then our y-intercept is 0 and 4. 1, 2, 3, 4. That's our y-intercept. Our turning points are, your minimum turning point is found at 2.786 and minus 8.0, minus 8.209, right? So that will be at 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So 8.20, negative 8.209 is like somewhere there. And 2.786 is 1, 2, somewhere here. So that's the minimum turning point. Okay? And your maximum turning point is at minus 0.120. So let's take somewhere here, right? And your other value is, it's very close to that value. Okay? And then what's left to do? Connect your dots. Okay? So, it'll look something like this. And this is your cubic function. This is y is equal to x minus 1, x plus 1. Then using the maximum and minimum points, intercepts, everything, boom.
How many maths?
Ish.
For the whole process.
They won't ask you specifically like this. They won't ask you like each thing. They probably won't even ask you because at this point they know that you'll know how to work out x and y intercepts. They just want to see it on the graph. So they won't ask you to do this whole calculation. Main thing they'll want to see is because the section falls under derivatives, they'll want to see that first part we did. You know the first derivative to get the maximum and minimum turning points? The second derivative to show where your point of inflection is, and then you must draw your graph out. But not bad. Okay? You just need to remember that a cubic function would look something like that. Everybody's okay? Any questions on this?
The minimum maximum makes sense now.
Yeah.
That's what we needed to see. Now it makes sense why it's going to be 0.
Yeah. Guys, you all okay?
Yeah.
Okay. Can I take it up? Okay. So this should have covered even if any confusions for last week's lesson, because we basically covered most of the methods we looked at last week. Now, okay, we've got a little bit more to go through for differentiation and then we're done with that, right? So I'm now on page 237. Okay? So 237 says sketching graphs to the form. Graphs. Okay, so please make a note by the heading or in your book or something that this is the cubic function. You remember in graphs, there was 9 graphs, right? And the 9th graph, when they said about cubic functions, they said we'll be looking at it in chapter 6. This is what we do in chapter 6, right? And also, remember that last question we did? This one I just did now on the board?
Yeah.
What type of graph was it?
Cubic.
Cubic function. So we actually did do a cubic function question there, but this is me making sure that you know it's a cubic function, okay? So they tell you example, y is equal to x cubed plus x squared minus 6x, okay? So the example, y is equal to x cubed plus, what is it?
X squared minus 6x.
X squared minus 6x. Okay, it's a cubic function because your highest exponent there is to the power 3. Okay, so we know it's a cubic function. So you would do this question like how you would do any other graph question. Okay, let's solve for our intercepts first. Okay, so our intercepts, if we're solving for it, we're gonna get, okay, let's say y-intercept let x equal to 0. So you will say y is equal to 0 cubed plus 0 squared minus 6 times 0. So your y-intercept is 0. So it will be found at 0 and 0. Okay? Then your x-intercept. You let y equal to 0. You left with 0 is equal to x cubed plus x squared minus 6x. Now you need to factorize. What can we do with this? You can pull out a common factor, right? So you can have 0 x into x squared plus x minus 6. All with me? Okay? So this would be 0 is equal to x into, if you factorize this, what does it become? So you have x plus 3 x minus 2, because x and x will give you x squared, plus 3x minus 2x will give you plus x, and then 3 and negative 2 will give you 6. Okay, so from here x is equal to 0, x plus 3 is equal to 0, x minus 2 is equal to 0. You can't forget about this one. Okay, so x is equal to minus 3, x is equal to 2. So your x-intercepts are 0 and 0, minus 3 and 0, and 2 and 0. So now we got our x-intercepts, we got our y-intercepts. What else we need to draw this graph? Minimum and maximum turning points. Okay, so for minimum and maximum turning points, right? What do? You derive, you get your first derivative, you equate it to 0. And you don't have to say it with me, right? Because the more you say it with me, the more it gets stuck in your head after that, right? So you need to let your first derivative equal to 0. So if you had to derive this equation, what would you end up with? Equal to 0. So now you just factorize this. Okay? So if you factorize it, what you left with? 3x. What did I get? Okay, you're not going to get a proper number, right? So let's use the quadratic formula, right? Or you could just, in your calculator, you could use your calculator, right? So you're going to press mode, but either one of the 3 ways, right? Whichever way you want to use.
I mean, it's not like you said no, I just said it go.
Yeah,
It's fine to do it.
yeah, that's fine. So you're going to press mode, okay? Then you're going to see, I think it's number 5 that says equation. All there? Okay? When you do that, you'll see one of the equations is ax squared plus bx plus c equal to 0. I think it's number 3. You're going to click it, right? So you're going to see on your calculator, you're going to see a column that has a, column that has b, column that has c. So in your a column, you're going to press 3, you're going to press equals to. It takes you to your b column. Then you're going to press 2, you're going to press equals to. Takes you to your c column. You're going to press minus 6. Don't forget the minus sign, right? Equals to. And then it's going to give you x1 and x2. It gives you x1 first. Okay, so what's x1?
1.11, okay, 1.120.
1.120 and x is equal to
Negative 1.786.
negative 1.786. You all got that?
Yes.
Okay? Fine. That's how you use your calculator to work for these. And you're going to need to know this method because, see this question here. Okay, I'll show you when I come to that part. Right? So your x-intercepts are, your critical values, are, so these are your critical values. You all agree?
Yeah.
You could have used this method. You could have tried to factorize it if you felt comfortable doing that. Or you could have used that quadratic formula, right? minus b plus minus the square root of b squared minus 4ac all over 2a, and you know your a value, b value, and c value. So either or, okay, that it doesn't matter. Because by now they know that you know how to solve for intercepts. That's not what they're worried about testing you on. They want to know if you can draw the graph, if you can plot your x-intercepts values, if you know your shape of the graph, you know how to know maximum minimum, because that's what we taught you. Okay? So now that we have this here, how do you get your turning points? Okay, so for your turning point, you're going to substitute it back into your original equation. So f of 1.120 is equal to 1.120 cubed plus 1.120 squared minus 6 times 1.120. And then you're going to solve for f of minus 1.786 equal to minus 1.786 cubed, 1.786 squared, 6 times minus 1.786. Okay?
Minus 4.061.
Minus 4.061. 8.209. Okay? So your turning points are 1.120 and minus 4.061 and minus 1.786 and 8.209. All of you are with me, right?
Yeah.
Okay? Now what do we need to know? Which is our maximum and which is our minimum. So we do the test. And how do you do the test? Or what is the test? Second derivative must equal to 0. So our first derivative is here. What will be the second derivative? 6x plus 2. Okay? So it will be 6x plus 2 equal to... No. You are lying to me.
We don't equate it.
You don't equate it to 0. You work out your second derivative, and if it's greater than 0, it's a minimum. If it's less than 0, it's maximum. So this is 6x plus 2. You all understand it, right? You seem bored. Bad. Okay, right? So f double prime of 1.120 is equal to 6 times 1.120 plus 2. F double prime of minus 1.786 is equal to 6 times minus 1.786 plus 2. Don't worry, I'm a teacher in a new section now, so okay. I know you don't know this, it's too easy, you're bored with it. But don't worry, I'll give you another one.
Favorite joke, sir.
It's too easy for you, man. You're so your marks are for the test. I mean, come on, Nick. This is too easy, all this. In the exam, I'm only expecting E, is that?
The first one is 8.72.
8.72. And this one?
Minus 8.716.
6. Okay? So, because f double prime x is greater than 0, this is a minimum point. And because this here is less than 0, it's a... So, we know our turning point here is... This one here would be minimum. This one here would be maximum. So now that we know this, we know enough for us to plot our graph. You don't need the point of inflection because it's not actually anything that's going to help you on the graph to draw it, right? So all you need to do is draw your graph. So graphs are big, huh? one goes up. Please draw your one more accurately. That's your y-axis. This is your x-axis. Okay. So intercepts first. Your y-intercept is equal to 0 and 0. One of your x-intercepts are also equal to 0 and 0, right? So we covered that point there. Your other intercept is minus 3, 1, 2, 3, minus 3 and 0 and 2 and 0. Okay? Turning points. Your turning point, your minimum turning point is 1.120 and minus 4.06. 1.12. Yeah. That's your minimum turning point. Okay? And your maximum turning point is minus 1.786 and it's on here. 8. Do I need to show the values for you or
No.
okay. So now we got this whole thing. You can see it before you even draw it, right? So all you need to do is connect it.
No, not finished.
Okay, so this is f of x is equal to x cubed plus x squared minus 6x. And show the points, right? So this point here would be minus 1.786 and 8.209. So when you go home and practicing it again, write down the points. 0.20 and minus 4.061. This here is 0 and 0. This here is minus 3 and 0. And this here is 2 and 0.
So, would it be correct in saying, unless you have a d value, your x and y intercepts will always be 0. There will always be a point that goes to 0. Unless there's a d value. Because if you substitute your 0 into...
Yeah, if there's no d value, you're going to pull out one x as a common factor. You're always going to have one point.
And if you get x equal to 0 in the equation, it will always have y will be equal to 0, x will be equal to 0. So you're always going to have a turning point
at the one
at 0.
intercept. Yeah, it's good or close to it.
Okay.
Okay, so this was sketching a cubic function. Okay, you see why we had to do it after is because you needed to know how to derive for your turning points. It's not like a parabola where you take minus b over 2a. You have to derive, get your first derivative, let it equal to 0, and then you get your turning points. Okay, but so far we're okay with this.
Yeah.
Okay.
If you don't test for your...
I know visually you can see how it's gonna
You can
be,
see
right?
how it's gonna
You're gonna, because no matter what, see if we never do the test, right?
Yeah.
You're gonna see that this point is here
Yeah.
when you plot it, and you're gonna see that this point is here. Okay, but sometimes they do ask you to just remember, like how the other one said, solve for your turning points and distinguish. Distinguishing means distinguish which one is your maximum, which one is your minimum. Okay, so show it. It's not
I'm just asking.
yeah, because majority of the time you're gonna have to use that same thing to do point of inflection on the next, like how the other question was, B into C. So if you're gonna do it, just do it on time, right? Okay, so that was a cubic function, right? Can I take it up?
Yeah.
Okay. Okay, now what happens in the instance if you have x cubed plus 3x minus x minus 3? Okay,
Wait,
you have that
x squared.
x squared. how do you solve for your intercepts? You're gonna have to factorize, right? But it's not straightforward factorizing like how you would factorize for a binomial. Okay? So you'll have to do something called a remainder factor theorem. But I don't want to confuse you all with that. Okay? It is a bit tricky, and I feel like you don't need to do it like that for you to get to it. Right? What you're gonna do is this. On your calculator, you're gonna press mode. Okay? The button mode. So when you press mode, you're gonna press 5 for equation. Yes? Okay? After you do that, you're gonna press 4 for the one that looks like ax cubed plus bx squared plus cx plus d. Does it equal to 0?
Yeah.
You're gonna press that. This here is for a cubic function. If you wanted for a parabola, it would be ax squared. So you're gonna press 3 for that. Ax squared plus bx plus c. This is for a. Oh, well, let's just say quadratic function. Okay, but for now we're using number 4. You press 4, right? So what you're going to do, you're going to insert A, B, C, D values, and then you're going to press equals to. So after each value, when you're putting an A value, you're going to put 1, right? Your A value is 1. You're all there, right?
Yeah.
You're going to put 1, press equals to. When you press equals to, it'll take you to the B column. You're going to put 3, press equals to. Your C value is minus 1, it's not 1. Press equals to, and then you take it to your D column, minus 3. Okay? And you end up with X values of minus 3, 1, minus 1. Okay? That's your intercepts, or if you have to equate the equal to 0. Okay, so if they give you a cubic function and they want you to solve for the values of x, please do it like that. Okay, because you know when you're going to end up doing it, you're going to end up doing it when when you're working out your intercepts and they say let it equal to 0, you're going to end up with that. So instead of using the remainder factor theorem and getting stuck with it, just do it like this and you can solve it. But if they gave it to you like how the other example was, x minus 1, x plus 1, x minus 4, they already gave it to you, so you can just write down your answers.
Yeah.
Okay, so you can take a picture of this method so you'll have it when you're learning. How are you doing 10? 10 o'clock. I always ask you 10, it's always standard 10. 10, half past 10, 11, half past 11. Okay. I'm now on page 239 at the bottom, right? You see they have that graph there? That graph is basically they plotted what these values were. They solved for the x-intercepts and the y-intercepts and they just plotted it, okay? But now I'm on 239. So this is very important because, can I take this part?
Yeah.
Okay. So this is important because if you have a graph of y is equal to x cubed, right? It's a cubic function. Yes, we all agree? Because your power is to power x, right? It's a cubic function. If you are to solve for your x-intercept, you're going to let y equal to 0. Okay? You let y equal to 0, what's your x value? 0. Okay? Solve for your x-intercept. You're going to let you're gonna no. If you're gonna let now you're solving for your y-intercept. You're gonna let x equal to 0. So what's your y-intercept?
0.
Okay, 0 and 0. Okay. Now you want to do your turning points. So you're gonna get your first derivative, right? will be y is equal to 3x squared, and you let it equal to 0. Okay, so like your first derivative here is going to be 3x squared. If you want the turning points, you let it equal to 0. Okay, what's going to happen? 0 divided by 3 is 0. Square root of 0 is 0. So you're going to come up with x values of 0. Second derivative, same story, you're still going to come back to 0. So how do you plot this graph? Okay, turn the page. You see at the part just before the graph they have in the bottom of 240, they tell you all these calculations do not help us at all because the graph of y is equal to ax squared is dependent on the sign of a. Okay? The sign of a, whether it's positive or whether it's negative. So, for example, if y is equal to positive 2x cubed, that's how your graph would look. It will go from your first into your third quadrant, or from your third into your first quadrant.
So it's always positive.
If your a is positive, right? And if your graph is a negative value, if that a value is a negative value, it will go from the second into your fourth. So if y is equal to ax cubed, your graph will look like, and it will cut through the 0 and it will go. If y is equal to negative ax cubed, your graph will look like that. And that's it. That is literally it. Okay, so this is if it's positive ax cubed. And they do ask this question. They ask this, guess how many marks they asked this question for in last year's in last trimester's test?
1.
6 marks, right? 6 marks. They told you plot the graph of positive ax cubed and negative ax cubed on the same axis. So all you would have done was you would have plotted this on top of this, and you would have called this negative ax cubed. You would have called that side 1. So you would have done this. You would have done
You show both.
like that. Both are shown on the same set of axes. You would say this is equal to y is equal to positive ax cubed, and for here you would have said y is equal to negative ax cubed. 6 marks. You would have labeled your axis and everything, but that's what you would have done. Imagine.
Almost the same as if they were xy is equal to -4. Or
Yeah, like how your rectangular hyperbolas and stuff is. And like even for parabola, right? Your parabola question, if I said the y is equal to x squared, right? Your a value makes it a smiley face if it's positive, and if it's negative, it's an upside down face. And even when it's y is equal to ax squared, you cut it at 0. You know, you draw the curve, it cuts at 0. Same story. So that covers cubic functions. Okay? And guess what? That also brings us to the end of limits and differentiation. Okay? So for limits and differentiation, we've covered what a limit is. Okay? Remember that one when we worked with the limits and then we took out our constants, and then all you do is you substitute it for the value that they give you. Like how you generally would do it in the equation. Right? Then we worked out limits in the form of 0 over 0. Right? What would you do in an instance like that? You would factorize to get rid of the terms that give you 0. And then you'd solve, you'd come out a number. Then we did for limits of infinity over infinity. Remember that?
Yeah.
How do you get that?
You divide the numerator and the denominator by the highest power of x in the denominator.
Right. You would divide the numerator and denominator by the highest power of x in the denominator. And we came up with a few things. Right? If your highest power in your numerator and denominator are the same, what's your value of the limit?
They are constant.
It's the constants of the highest powers, right? If your highest power is in your numerator, what's your value of the limit as it approaches infinity? If your answer is approach infinity, right? And if your highest power is in the denominator, 0. Now remember all this, right? You'll need to go recap, right? But you'll know this, right? You've all been here. limits, that was limits. Then we did differentiation from first principles. Okay, that was your derivative is equal to the limit as h approaches 0 of f of x minus, f of x plus h minus f of x all over h. And then you solve, remember you'll end up with an h term cancelling. And then you let h equal to 0, you end up with your term. Okay? Then we did binomial theorem. Actually, we did binomial theorem first. Right? We did binomial theorem first, where you have that one there was x plus h to the power n. And then you'll end up with xn plus n times x to the power n minus 1, so on, so on, so on. Remember? Up to the first 4 terms. But when you're using it in first principles, how many terms you take? 3. Because what happens after a certain point, everything cancels out. It just becomes 0 towards the end. Right? That was limits from first principles, there was binomial theorem. Then we did differentiation using the shorter method of the rules. Right? Like how we add x to the power n is n times x to the power n plus 1. Those rules. Then 1 to 16. 15, right? Then we did chain rule. Chain rule is used for a function of a function. And how would you use the chain rule? What is the chain rule? dy over dx is equal to dy over du times du over dx. So you would let the function that has the independent variable x equal to u. When you let it equal to u, you derive and you substitute and you solve. Now when they did the chain rule, they came up with equation 16 to 25. And we learned how to use that to solve for questions. Then we learned the product rule. Now your product rule says that dy over dx is equal to u times dv over dx plus v times du over dx. And then we also did the quotient rule. Quotient rule is for dividing. Then we did maximum and minimum turning points. Yes? To get your turning point or your critical value, you let your first derivative equal to 0. Okay? You get your critical value. Substitute it back into your original equation, you get your intercepts for your turning point. Okay? For point of inflection, you let your second derivative equal to 0. And then we learned how to do our cubic function. And we covered everything over there. It sounds a lot, it sounds crazy, but you have done each part, you'll know each part. Just a matter of going back and practicing. Okay, main thing is practicing. So now, that just say your test covers 6 questions. You know how to answer question 1, determinants. You know how to answer question 2, complex numbers. You know how to answer question 3, trig. You know how to answer question 4, graphs. You know how to answer question 5, which is limits and differentiations. So the only thing left to do now is learn integration. And that's where we are now. Okay, let me stop this video and then I start with number 4.